Okay, this is question 10 from the 2011 exam. We need to find the dual of this problem, but we do not need to solve the problem any further. So I will write down the theory for the dual problem so we can actually have it on the side and look at it while we do the exercise. So this is here everything we need to solve the problem. Now we can go to our LP problem. This is our primal problem, and we can see that it is a maximized problem, so that's good for us. We don't need to change anything here. But looking at the constraints, we can see that they're all greater than or equal to inequalities, and we need to change that since we want the inequalities to be less than or equal to inequalities. So we need to turn them into their standard form. And we do that by multiplying all of them by -1. So multiplying by -1 will give us minus x minus 2y is less than or equal to -7. 3x minus 5y is less than or equal to -5. And we will have minus 6x minus 7y less than or equal to 3. And again, x and y greater than or equal to 0. So now the problem is in standard form, and we can proceed to find its dual problem. So we can see that the vector c here is just 2 and 8, which is the coefficients of x and y in the objective function. The matrix A is just the coefficients of x and y in the constraints, and then B is just the vector of the resource constants. So the dual problem will be minimize y is equal to B transpose, as we said before, B is this one. So we will have minus 7u1 minus 5u2 and plus 3u3. So this will be our objective function. And now this will be subject to, we need to take A transpose. So here A is -1 minus 2, 3 minus 5, and minus 6 minus 7. So transpose will give us the inequalities minus u1 plus 3u2 minus 6u3 and minus 2u1 minus 5u2 minus 7u3. And these will be greater than or equal to C transposed, where C is just 2 and 8, so we'll have 2 and 8. And also UI greater than or equal to 0. Don't forget to write that down. So this will be the dual problem, and now we will just write it down in standard form and as a maximized problem. So that will give us maximize. When we turn a minimize into a maximize problem, what we do is we just multiply the objective function by -1. So we will have minus y equals 7u1 plus 5u2 minus 3u3. And that will be subject to, again, in order to turn these into less than or equal to inequalities, we just multiply by -1. So we will have u1 minus 3u2 plus 6u3 is less than or equal to -2. And then 2u1 plus 5u2 plus 7u3 is less than or equal to -8. And again, ui is greater than or equal to 0. So this is going to be our final answer. And since we do not need to solve the problem any further, this is all we need to do. and it's nice and easy.